Hey science students, it's Miss Creasman with a review of the brain drain for your 8th grade science STAAR test. Just remember the point of a brain drain is to drain your brain at the beginning of the STAAR test so that you can remember everything you need to know while your brain is still fresh. So remember, STAAR's really long, you get tired, it has lots of ways they like to try and trick you. But if you do your brain drain and complete all of this information, this is a sample one, should have it glued in your notebook somewhere, then it makes it really easy when you get toward the end of the STAAR test and you're getting tired, you can just check here for answers. This basically is giving you answers if you take the time at the beginning of your test to get it done. Usually by the time y'all have practiced this, it takes you less than 10 minutes. You get 4 whole hours to take your STAAR test, so I think it's totally worth it to spend the first couple of minutes, rip this out of your test booklet, and do a brain drain to get you started. When you get a STAAR test booklet, it looks similar to this. This is an old one. First page is your reference sheet and your periodic table. So that's a reminder that the very first thing you do before you even read the first question should be to rip this out, put this to the side, and get started with your brain drain. Okay? Then as you're answering test questions later and you already have this completed in front of you, you always should be asking yourself, can my brain drain help me answer this question? That way you'll always be referring back to this and using it, and it gives you answers. You don't have to think about it. Okay, so we're going to start going through this. We're always going to start with the front side, and we go through it kind of in the order that we learned it. So, for this video, what I want you guys to do is you should have your own science STAAR reference sheet in front of you, and you're going to copy what I'm doing, okay? So you're going to write down everything I write while I'm writing, and then at the end of the video, you can stop the video and practice again to see if you can remember all of it on your own, so that you will be prepared to do this when you get your STAAR test. So when we started chemistry, we started with atoms. So I'm going to go up here to this top right corner and draw my reminder for atoms. So remember, for atoms, we have no peeing in the pool. No peeing in the pool, guys. That's gross. So the neutrons and protons are inside your pool, and electrons can't swim. So they're really negative, and they are sad that they don't know how to swim. So already, with this diagram, it reminds me of a couple of things. It tells me the particles' locations and their charges. So that reminds us that our protons and neutrons go in the nucleus and that our electrons go on the electron shell or electron cloud or electron orbital or energy level. Any of those terms work for this. And then it also reminds us of our charges. So protons are positive, neutrons are neutral, and electrons are negative. So I'm going to go ahead and label this as our nucleus. And when we label a nucleus, there's something really important to remember about the nucleus, and that is it is the densest part of the atom. And it holds all of the mass of the atom. Meaning, when you look at an atom's atomic mass, that number comes from the number of protons and neutrons added together. So we need to remember that's the densest part with the most mass. Because if you remember, our protons have a mass of 1 AMU, neutrons have a mass of 1 AMU, but electrons only have a mass of about 0 AMU. So your protons and neutrons are much bigger. That's what makes the nucleus so dense. And then the last reminder we want right here is for our protons. And we want to remember that protons always determine the identity of the atom. Okay, so if you're looking at an atom with 2 protons and all of a sudden you add a proton, you're no longer looking at the same atom. It's kind of like your ID number. If I change one number in your ID number, it no longer represents you. So atoms are the same way, and that number comes from the number of protons. So now make sure you have that atom done, and we're going to move over here to this labeled symbol. The next thing we learned with atoms was 8-man. So this helps us to remember how many total protons, neutrons, and electrons that we have in any atom. And I'm going to line this up like this. I want to line up my ape with the atomic number, because that A stands for atomic number, and I lined up my man with the atomic mass to remind myself that that's what my M stands for. You also need to make sure that you remember where this minus sign goes. So it's A equals P equals E, M minus A equals N. So now we're going to write what each of those stands for. So we have atomic number equals the number of protons, which is also going to equal the number of electrons. And then we have man, so atomic mass minus the atomic number will equal the neutrons. And if you get in habits of writing those little symbols, every time you write those words, your brain starts to remember the charges of the particles. And then every time we do 8-man, we always summarize it with P-N-E, so that we know exactly how many protons, neutrons, and electrons. And again, we have P plus and neutral E negative to help our brain remember the symbols. So make sure you have that. After atoms and 8-man, we started to study the periodic table, and one of the first things you learned was about groups and periods. So up here, I'm going to add my group and period L, and my P always goes in the corner. So if my P is in the corner, then that means group goes up and down like that, while period goes side to side. And then you might notice I drew my O's a little funky. Okay, but that actually helps you remember what group and period can tell you about an atom. So the group number of an atom tells you how many valence electrons it has. So I drew a little dot on my O to look like a valence electron, kind of like my little electron over here. Remember, valence electrons mean the number of electrons on the outside shell of the atom. And then I drew this O with 2 rings because periods tell us the number of electron shells that an atom has. So that kind of looks like electron shells. So now, using my group and period L, I can use that to remember the directions of my groups and periods on the periodic table. So if I lay my pencil along group, then that helps remind me that my groups are the up and down columns. So next to each of those numbers for my groups, I'm going to write a G all the way across so that I know that those numbers are my group numbers. So you have 18 groups, and then if I lay my pencil along a period, then that helps remind me that my periods are the rows that run horizontally. So then over here next to these numbers, I'm going to draw in my p's. And there are 7 periods. And then looking at our group in period L, this reminds us that periods tell us the number of electron shells. So any element found in period 1 will have 1 electron shell. I'm just going to label that so that I know that that's an electron shell. So remember that little E minus just means electron. Anything in period 2 will have 2 electron shells. Anything in period 3 will have 3 electron shells. And then it just continues. After that, those electron shells start to get a little too big, so I just write dot, dot, dot. But you should know that anything in period 4 will have 4 electron shells, period 5 will have 5 electron shells, period 6 will have 6 electron shells, and period 7 will have 7 electron shells. Then for our groups, our group in period L reminds us that groups tell us the number of valence electrons. So anything in group 1 has just 1 valence electron, and I'm going to label that. You can just write VE as long as you know that that stands for valence electron. And any time that you ever see something about valence electrons, you want to associate that with the atom's chemical properties and reactivity. And anytime that you ever see something about chemical reactivity, that is associated with the number of valence electrons. So this is a major word association on STAAR. If you have a question about valence electrons, the answer usually is going to have something about chemical properties or reactivity or how it bonds. If you see something about reactivity or bonding or chemical properties, it's going to have something to do with its valence electrons. Okay, so group 1 has 1 valence electron, group 2 has 2, group 3 we actually skip. So do not forget this part. This middle section from group 3 to group 12, we actually don't put any valence electrons for these. So this area is known as the transition metals. So what I want you to think is that we don't talk about the transition metals until you transition into high school. Okay? So these are still groups. If I were to ask you what group iron is in, you would still tell me that it's in group 8. But if I were to ask you how many valence electrons, you wouldn't tell me anything about its valence electrons or reactivity. Okay, the transition metals are a little bit different properties, so we don't talk about them until we transition to high school. So we're going to skip all the way to here. Once we get across to this side, there's a little trick you can use to remember the number of valence electrons. And it says, take your thumb, cover the 1, and that's how many valence electrons you have for these groups. So in group 13, you have 3 valence electrons. In group 14, there's 4. So make sure you're doing this with me. In group 15, those atoms have 5 valence electrons. Group 16 has 6. Group 17 has 7. And finally, group 18 has 8. And there's one special exception in group 18, and that is helium. So over here, helium only has 2, so we remind ourselves just by putting only 2 right there next to helium. Okay, and group 18 is pretty special when we talk about reactivity. Group 18 elements all have a full outer shell of 8 valence electrons, or 2 for helium, So we call them the noble gases. So we're going to label that. Now I'm going to pause here to teach you a little trick for a second. Okay, I know a lot of times you guys don't like to write over the elements in the periodic table. I know sometimes that messes it up where you can't see the numbers in case you have to answer a question about that element. So you guys can ask for highlighters on the science STAAR, just like on any other of your STAAR tests. They will not come around and give you a highlighter, but if you ask, highlighters will be available to you. So this is a great option to use to label your periodic table. So if I use my highlighter to label my noble gases, then I can see that label and I can still read the information about all of the elements. So group 18 is known as the noble gases because of their full outer shell, which means that they don't react. They will never react with anything, which is also known as being stable. So if group 18 doesn't react and they're stable, then we want to know which groups are the most reactive. So that would be group 1, which is very reactive because they only have one valence electron, so they are desperate to get the rest of them to be complete. So we write very reactive right there. And then also group 17, because they already have 7 valence electrons, so they're actually also really desperate just so they can get that very last valence electron that they need to be complete. So here we also write very reactive. So now we have a little summary of our reactivity trends down at the bottom if we have reactivity questions. And then we're almost done with the front side. The last thing that we're going to do is label our metals, nonmetals, and metalloids. So our metals are to the left, or the central part of the periodic table. And I'm going to use my highlighter again so that I can still read all of my elements when I'm done. Okay, my nonmetals are to the right side. And noble gases are actually still nonmetals. So a gas would be a nonmetal. They have their own specific name, so we still label them. But as far as metals, nonmetals, and metalloids go, they would be considered nonmetals. And then hydrogen is actually also going to be a nonmetal. It's the one weird one over here, but it's grouped in group 1 since it only has one valence electron. So I just write a little NM up there. And then lastly, the staircase is our metalloids. Before I write that, though, I'm going to show you a quick little trick. Okay, I know a lot of people get confused about which elements actually are the metalloids because some of the ones touching the staircase are not actually the metalloids. So there's a little trick that you can remember to know which ones are the metalloids. It's a rhyme. It goes like this. Boron, silicon, down, across, down, across, down, across. Okay? And you could even color them in if you wanted. So you have boron, silicon, down, across, down, across, down, across. So last time, boron, silicon, down, across, down, across, down, across. So that can help you determine the ones that are actually the metalloids, so that if you had a question about metalloids, you would make sure that you knew which ones they are. And now that we have that labeled, our whole front side is done. So go ahead and make sure that you have all of that. And then we are going to move to the back side. So for the back side, first thing that we have up here at the top is our formula chart. Oops, wrong way. Okay, so for each formula, lucky for you, you don't have to have any of these formulas memorized. They're already written here for you. So anytime you need a formula, if you're not sure what to do, look here, figure out which of these variables that you have in your question, and that will give you the formula you need. So next to these formulas, we're just going to write a few things about them so that we know when to use that formula. Okay? So density is mass over volume. So density, we want to remember the definition of density so that we know that in case it's asked. Density means how tightly packed the particles are in a substance. So we've talked about this a lot with weather and convection currents, and we've compared the density of cold and warm air, or cold and warm water, or cold and warm magma, and we looked at those two images to compare their density. So density means how tightly packed the particles are in a substance, and density is used to identify an unknown substance. Used to identify an unknown substance. So maybe in 6th grade, you might have measured the mass of something using a triple beam balance, measured the volume using a graduated cylinder or a ruler to solve and find the density. And then usually when we find the density, the whole point of that is to identify or ID an unknown substance. So they'll usually give you a chart with a list of known densities, and you'll have to figure out which substance you actually had in your hands. Okay, speed. Average speed equals the total distance divided by the total time. Usually when we talk about speed, we're comparing that with velocity and acceleration. So if we're talking about a definition of speed, that just means how fast something is going. Compared to velocity, velocity just means speed in a given direction. So if you are asked to calculate velocity, it doesn't have its own formula. You're still going to calculate speed, and you're just going to give your answer with a specific direction. So for example, if you were to calculate a velocity, you would want to first calculate the speed, so you would still use distance over time. If you got something like 60 miles per hour, your answer, if you were asked for velocity, would not be 60 miles per hour, but it might be something like 60 miles per hour north, because that way you include a direction. And then we can compare both of those with acceleration. Acceleration means any change in speed or in velocity. So velocity includes speed and direction. So basically it's any change in velocity. So the way we could change our speeds would be speeding up, or you could slow down, and then the last way to change, to accelerate would be to change your direction. So remember that little triangle means change. So acceleration includes speeding up, slowing down, or changing directions. Our last formula is net force, and this is one of Newton's laws. So this is Newton's second law. Force equals mass times acceleration. So we're just going to label that that's Newton's second law. And then out to the side, we just want to remind ourselves what the other two laws are. So Newton's first law is the law of inertia. So inertia says that an object in motion will stay in motion, and an object at rest will stay at rest until an unbalanced force acts on them. So remember, unbalanced forces are what makes the object continue in constant motion. Nope, that's a lie. That's balanced forces. Unbalanced forces are what change the motion of the object. And finally, Newton's third law is called the law of action, reaction, which states that for every action there is an equal and opposite reaction. So make sure that you have those formulas all done and written. And now if I zoom out, with the bottom of this paper, we're going to divide it into 3 sections for our last 3 parts. So I'm going to just divide this first part down the middle. And then on the right side, I want to divide this into 2 sections. So you're making kind of a sideways T shape. So I'm going to go up here to this top box right underneath the formulas on the right side. And this is going to be where we are going to write about chemical reactions. That's an abbreviation for reactions, RXN, or RXNS. So remember, this is your brain drain. This is for you, so you can use abbreviations as long as you know what they mean. And with a chemical reaction, that means that a new substance is going to be created. So chemical reactions means that you mixed 2 things together, and then you got a new substance. And the way that we remember if we had a chemical reaction is with our mnemonic device. City, girls, really, love, their phones. City girls really love their phones. So that gives us the first letter for each type of chemical reaction. So remember, it's a new substance. It's always something unexpected when we mix 2 things together. So C stands for a color or odor change. Remember, the triangle means change. So when you think odor change, think of something baking or cooking and you smell it across the room. Usually you get a color change with that too because it gets darker. Or if you mix something green and blue and it turns red, that's a color change. If you mix something red and clear and it becomes a lighter red, that's just physical because that's what you expected. Okay, G stands for gas and bubbles. So bubbles are evidence that a gas is being created. So that's why those go together. R is for rust or corrosion or tarnishing. So rust is something that happens to metal, usually like if you leave it outside and it gets wet and then it rusts. We've probably all seen a little bit of that on our bikes or an old rusty nail. Corrosion is something, it usually happens with something like batteries. If you've ever had an old remote and you open up the batteries after a long time, it has kind of some white crusty stuff. That means it's corroded. So that's kind of like a color change. Rust is also like a color change, and so is tarnishing. Tarnishing is something that happens to silver, so something like silverware or silver jewelry, and it gets like black stuff on it, and you have to clean it to get it off. So that's a chemical reaction, and it's kind of like a color change. So anytime you see any of those words, those are chemical. L is for light, burning, or smoking. Because usually if something burns, it's going to smoke. Okay, anything that produces a light, usually it's producing a light because it's burning, but sometimes there's some chemicals where you could mix them together and all of a sudden it gives off a light, or burning, or smoking. T is a temperature change. Remember, that comes from mixing two things together. So if I put water in my ice cube tray in the freezer, and it turns into a solid and it gets cold, that doesn't count as a temperature change chemical reaction because I did it on purpose and it was only water, so I didn't mix two things together. Okay? And then lastly, we have precipitate, not precipitation, precipitate, which means to form a solid. And again, this does not mean that the whole thing turns into a solid. It means you mix together two liquids and you get a cloudy liquid, or you get a chalky looking substance, or you get some grittiness. So it's just a little solid that forms inside the liquid. Okay? So anytime you have a question that's asking you if a new substance is being created or if a chemical reaction is occurring, you have to see if it's on City Girls. Dissolving, not on City Girls. Absorbing, that's not on City Girls. It has to be on City Girls to be chemical. Unless it's something that fits in with City Girls. So make sure you have that. And for our next part, we're getting close to being done. We're going to turn it sideways and use this big rectangle for our moon phases. So, moon phases, it takes about 28 days for the moon to revolve around the Earth. Which means each phase takes about 3.5 days. EA means each, 3.5 days for each phase. When we draw moon phases, the sun always goes on the right. The sun is way bigger than the Earth or the moon, so I only drew a little sliver of it. And then we're going to put the Earth in the center. And then we have 8 moon phases. And the moon revolves around the Earth in a counterclockwise direction. So we're going to draw our arrows counterclockwise. And this is the reason it's called the moon bullseye, because we have kind of our bullseye in the center. So then, if we are standing on Earth and looking at this moon, and the sun is shining this direction, then we are not going to see any of this moon when we are on the earth. So when we don't see any of the moon, that is called new moon. It's the first moon phase of the month. But on the opposite side, if we're standing on the earth and the sun is shining all the way across and we're looking at the moon in this position, we're going to see this moon completely lit up, which means this is our full moon because we can see the full moon. So remember with moon phases, the black part is the part you can't see, so it would blend in with the night sky. The white part is the part that you can see because the moon is white. Okay? So then, as we go from new moon to full moon, during this portion of the month, when we can't see any of the moon, and now we can see the whole moon, that means it's getting bigger. So we're going to call that waxing. Because waxing means getting bigger. So that goes from here all the way across to this side. Then from full moon back to new moon, the amount of the moon that we can see would be getting smaller because we're going from seeing all of the moon to eventually seeing none of the moon. That is called waning. So anything on the bottom half would be waning. And then we're going to use a little trick to fill in our moons. It's O, backwards C, I, C. O, backwards C, I, C. So we're always going to start at new moon. That's already an O shape. Okay? And then we're going to go backwards C, I, C. So that's your O, backwards C, I, C. O, backwards C, I, C. Now, with your backwards C and your C, this is really important. Sometimes I see people that do their C like that. Okay, that's not any type of moon. I've never seen that type of moon in the sky. So, be careful that when you're doing your C, it should be close to the edge to make that crescent shape. And same for your backwards C. Your backwards C shouldn't be like that on the edge. You want it to be close to that edge to make that crescent shape. So just be careful with those C's and backward C's. Okay? And then we need to fill in our moons. So we have a trick. We're going to go to the left, to the left, to the left. Everything you own in a box to the left. So we're going to Beyonce to the left, skip, and then Cupid shuffle to the right, to the right, to the right. Okay, so that means I'm going to shade in the left side, left side, left side, skip, full moon, and then I'm going to shade to the right, to the right, to the right. So, you see I shaded the left side, left side, left side, skip, to the right, to the right, to the right. Okay? Now, these two moons, the shape that we have left, the white shape, is called a crescent. So we're going to label that right here. And these two moons, the white part is called a gibbous. Gibbous. So now we can name each moon, because usually if you have a moon phase question on your STAAR test, it's going to be asking you for the name of the next moon. Sometimes that might be the picture. Okay, so this one, since it's on the top half, it's waxing. And since it's right here, it's a crescent. So together, that's a waxing crescent. This moon is called a first quarter. You can think of it as being 1/4 of the way through the moon phases. This one, since it's on top, it's waxing, and since it's here, it's a gibbous. That makes it a waxing gibbous. We already have our full moon labeled. This one, now it's on the bottom, so that's going to be waning and gibbous. Then this one is our 3rd quarter. Because now we are 3/4 of the way through our moon bullseye. And then lastly, this one is on the bottom, so it's waning, and it's here, so it's a waning crescent. Now, 2 quick things about the moon bullseye. On your STAAR test, the sun might not always be on the right side on a question. So if it's not, what you need to do is turn your paper to match the moon bullseye. Okay, so for example, this question, this is an old STAAR test. Here's the Earth, here's the moon. Sunlight is coming from the left. So what I would do, turn your STAAR booklet upside down so that it matches your moon bullseye. So now my sunlight's on the right, my Earth is here, and I can pretty easily see that that moon would be this moon based on its location. So now that just made this whole question so much easier. If I flip this back around, I can find the one that is the waxing crescent. Boom, done. Just because my moon phases were already written. The other option could be to turn your moon bullseye, and you can do the same thing. Now my suns are on the same side. I can figure out my Earth is always in the center, so it still looks like it would be that moon. Same thing, it's already labeled, same picture. Match. You didn't even have to think about that question. It just gave you the answer from your brain drain. Okay? And then the last thing, a lot of times with moons, they ask you like how many days it will be when you see a next phase. So if they're 3.5 days each, 3.5 plus 3.5 means 7. So every 2 phases is 7 days, which makes sense because if you think 4 phases, 7 times 2 would be 14. 14 is also half of 28, so if we go halfway through the moon bullseye, that's 14 days, or 2 weeks. So then if we go 14, and then 2 more, that's 21, and then 2 more is 28. So make sure you know how to use this information to find how many days until the next moon phase that you need. Last part, so close, we are going to review rotation and revolution. So usually with rotation and revolution, you will see a diagram kind of like this, where you might have the sun in the center for Earths, and you figure out the seasons at a specific location. For our brain drain, we're just going to draw one Earth so that we know how to do it, and then we can figure it out on an actual STAAR question. So first, for rotation, which is also known as rhodation, we're going to put what rotation causes and what revolution causes. So rotation or rhodation causes day and night. And then revolution or revolution causes the 4 seasons. A lot of times when you have a question on STAAR about revolution, what they're going to ask you to do is label the seasons. And in order to do that, you have to know the seasons in order. So down here, we're going to label the seasons. We're going to start with fall just because it's easiest to remember the seasons in order of our school year. So we start school in the fall. Okay? Our first big break after we start school in the fall is winter break. 2 weeks off. After winter break, we come back and we have to wait forever, it feels like, until spring break. And then after spring break, our big break at the end of the year is summer. Okay, so this can help you remember the seasons in order if you think about your school year. Fall, winter, spring, summer. And you can start at any place and still go in order. Okay, so we're going to draw our sun on the right, just keeping consistent with our moons. And I'm just going to draw one Earth with the axis tilted like that. My equator in the center. Okay, and then there's 2 ways that you can figure out which season is occurring on each hemisphere. The best way is probably this one. Lay your pencil along the Earth's axis. So I just line that up with the 2 lines that I drew along the axis. Whichever end of your pencil is closer to the sun would be experiencing summer. So this end of my pen is closer to the sun. So I'm going to go ahead and label this as summer. Okay, the other way I could have figured that out is if I draw an arrow straight from the sun to the earth. This one's hard because it's hard to draw straight sometimes. That means that this is getting direct sunlight. When it's getting direct sunlight, that means it's summer. In order for the sun to reach the northern hemisphere, in this case, that's north, that's south, the sunlight would have to curve up. When it has to curve like that, that's called indirect sunlight, which means that this is going to be winter. Sorry, I drew my earth a little too small. I'm having to squish that in. Okay? So remember, whenever you are figuring out seasons, you always want to start on an earth that is either to the left of your sun or to the right, because those are going to be summer and winter. So normally when you have this diagram, your sun's in the center, so you would have an earth here, 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 and here. So you always want to start at one of these. Those are going to be winter and summer. These will be fall and spring. So you have to start here, figure out winter, summer first, and then go to the next one. So just to remind you kind of what the diagram usually looks like, I'm going to draw a small version over here. So usually you have your sun in the center. And then you usually have all 4 Earths. One to the top, left, bottom, and right. The Earth also revolves around the sun in a counterclockwise direction. So I'm going to draw in my arrows. And then lastly, I'm just going to put a little star by these 2, because that's where you would always want to start, is either your left or right, to find summer and winter and then go around. So make sure for any rotation and revolution questions you pay attention to which hemisphere it's asking you the season for, the north or the south, and which direction it's going. Last thing we're going to do, we figured out the seasons. We need to figure out where it has day and night. So remember, day and night is not divided along the Earth's axis. The light doesn't care where the axis is. It just goes straight up and down. So I'm going to divide this up and down. Anything that is to the right side of my line is facing the sun, so it would currently be in daytime. Anything on this side of my line would be on the opposite side of the sun, so that would be in nighttime. Okay, now that is it. I would highly recommend you practice this. Make sure that you know it. I know it felt like it was long, but once you practice it, it goes a lot faster than you think, and it is so helpful on your STAAR. Okay, so I want to encourage you to do this. Use it as we are doing STAAR review, and hopefully you'll be able to see how helpful it is to you. So go ahead, and when you finish this video, go ahead and turn off the video. Get yourself another brain drain. We have plenty. And do it again. Do it from memory. See what you remember. Okay? This will only help you. Okay? So, thanks for joining me. And practice your brain drain. Don't forget, it should be the very first thing you do on your STAAR before you even read question number 1. Practice, practice, practice.